Hi there, my name is Kyle Borgert. Welcome to the IECM tutorial on the cost of carbon dioxide mitigation. This video will walk you through the steps necessary to calculate two of the primary metrics of interest for carbon capture equipped plants: the cost of CO2 avoided and the cost of CO2 captured. We assume that you are already familiar with the basic functionality of the IECM and are comfortable with opening and saving configured plants. So let's begin by loading a typical new source performance standard coal plant. And then adding an amine capture system for CO2 control. Then, in order to save time, under set parameters, I'm going to accept all of the IECM defaults, except that I would like the model plant to have a net production of 500 megawatts of electricity. So under the base plant tab, I'm going to modify the gross electrical output so I get 500 megawatts in the results tab. If I iterate quickly, I find that the required gross capacity is 615 megawatts. If I then go to the Get Results section and look at overall plant, I can see that I have 500 net megawatts. Transitioning to cost summary, I see that total revenue for this plant is $101 per megawatt hour required. As you know from other IECM videos and documentation, this represents the levelized cost of electricity generation expressed here in constant 2010 dollars. The additional cost parameter we're now after is the cost of CO2 avoided. In Get Results, under the CO2 Capture tab, the last bottom tab, called Summary, contains an area for CO2 avoided. If you're not already familiar with this parameter, you should consult the IECM documentation or technical literature for the relevant formula. Essentially, this is the cost of avoiding a ton of CO2 emissions to the atmosphere while still providing a unit of useful electricity from the power plant. The important thing to remember about the cost of CO2 avoided is that it is a relative measure that compares a plant with CCS to a reference plant without CCS. Another important factor is that it should include the full costs of carbon capture, including transport and storage, as well as capture. Because you haven't avoided emissions to the atmosphere unless and until the CO2 is sequestered, not just captured. Right now the avoidance cost is zero because we haven't yet specified the reference plant. The reference plant need not be the same type of plant or have the same net electrical output as our CCS plant. For this example, however, we will assume that we had the option of building a traditional pulverized coal plant of equal net electrical output in lieu of our amine-based CCS plant, keeping all financial and operational parameters the same between our CCS and reference plants. To do this easily, we will create our reference plant by modifying our existing session rather than creating an entirely new one. First, though, I want to save this file as CCS. Going back now to the Configure Plant tab lets us remove the amine system. When we did that, the Configuration drop-down menu now recognizes this plant as a typical new source performance standard plant. Due to the large parasitic load that is typical of an amine-based CO2 capture system, if we go to Get Results, Overall Plant, and then Plant Performance, we see that we are now producing 575 megawatts of electricity rather than the desired 500. After a couple of iterations, I found that using a gross output of 535 megawatts gets me the desired net output of 500 megawatts. Now that we have the output matched, let's save this modified session as reference using the Save As function. Depending on your computer, it could take 20 seconds or more to save this file. So while it is being saved, let me mention that it's not essential that the reference plant and the CCS plant have the same net capacity. If they don't, however, the cost of one of the plants will be skewed a little higher or lower depending on its size. This can make a small difference in the avoidance cost which you calculate. With the reference session saved, reopen the CCS session. Then move the tiles so you can see each clearly. Then select Set Parameters, Overall Plant, and then the reference plant. Shown in blue highlighting are the two parameters which we need to specify from our reference plant: CO2 emission rate and cost of electricity. In the reference plant session, under Get Results, the levelized cost of electricity can be found under the Cost Summary tab. We can now key in the $59.75 per megawatt hour into the CCS session for the reference plant cost of electricity. The CO2 emission rate of our reference plant can be found by selecting Stack and then the lower Flue Gas tab. Scrolling over, we can see that the total output is 451.7 tons per hour for carbon dioxide, which is not in pounds per kilowatt hour, which we need to provide for our capture session reference plant. We can easily change the table units to mass per kilowatt hour, however, by selecting View, Result Tools, and then changing our performance table units to mass per kilowatt hour. The value of 1.806 pounds per kilowatt hour is now listed for CO2 emissions and can be keyed in to our CCS session. Having keyed in our reference plant CO2 emission rate, we are ready to view results. In the CCS session, under Get Results, CO2 Capture, and in the lower Summary tab, we find that the IECM has now calculated our measure of interest, an avoidance cost of $53.50 per ton of CO2. Remember, though, that we've been using English units, so this is the cost per short ton. If we want it in metric tons, which is the way most avoidance cost figures are reported in the literature, we need to change to metric units. That's easily done using the results tools, and the new cost is now $59 per ton. Also provided on the screen is the added cost of electricity due to CCS, which is about $42 per megawatt hour for this configuration. This represents a roughly 70% increase in the levelized cost of electricity compared to the reference plant. There's one more cost we want to look at, which is the cost per ton of CO2 captured. This is of interest in cases where there's a market price for CO2, such as for enhanced oil recovery, and you'd like to know whether that selling price would pay for the cost of installing a capture system. Because of the additional energy needed to run the capture system, more CO2 is captured than avoided, so the cost per ton captured will be less than the avoidance cost. Furthermore, since we're only interested in the cost of capture, we exclude the cost of transport and storage from the overall CCS cost. Again, the formulas for these calculations are found in the technical documentation. Using the IECM, there are two ways to get a cost per ton of CO2 captured. One method is approximate, the other method is more rigorous. The approximate method is to just move to the Total Cost bottom tab under CO2 capture results. You see in the third column of figures the total cost of $24.50 per ton of CO2 captured. This value excludes the cost of CO2 transport and storage, as it should, but it also excludes any added costs in other sections of the plant that were necessary to install a capture system, particularly any upgrades to the FGD system relative to the sulfur removal requirements of the reference plant. The other factor that affects this result is the assumed cost of energy supplied to the capture unit. This is often an arbitrary choice that you have to make if you want to allocate the total cost of the plant to an individual component. For example, if we go back to set parameters, overall plant, and then O&M costs, we can change the internal cost of electricity from the base plant to the total plant cost of electricity. Checking the cost of CO2 captured, we see that it has now jumped to $30 per ton. That's because this is an energy-intensive process, so the assumed cost of energy has a significant impact on the result. For other components that don't use a lot of energy, the effect of this assumption may be small. A more rigorous way to calculate a cost of CO2 captured is to again compare the cost of electricity for the plant with capture, but no transport and storage, to a reference plant without capture, as we did for the avoidance costs, but then divide by the amount of CO2 captured. The IECM is not currently set up to make that calculation automatically, but it's a simple calculation you can make if you need that result. You'll need the total quantity of captured CO2, which you can find under the Results tab for the overall plant, under the Mass In and Out tab. Here it is. Just use the results tools to get this in units of kilograms per kilowatt hour. If you use the same reference plant as before, the result should be about $35 per ton of CO2 captured, which includes all the cost differences between the two plants. So the cost per ton captured is about 40% less than the cost per ton avoided for this example. We hope that you find this methodology helpful in your carbon capture modeling efforts, and we thank you for watching.